ก็เลยเรียนแจ้งตรงนี้นะคะทีนี้ขออนุญาตเข้าสู่เทคโนโลยี presentation นะคะเดี๋ยวmay I start technology presentation and invite Professor Pan to be the first speaker.
Good afternoon. I will introduce my speaker, but I shorten my content. So just to tell you about why we need to use AI-based for test research circularity. Actually, this primary auditor is Dr. Xie, Professor Xie. But now he has an important project to handle. This project is about his funding, about the next year's funding, so he cannot attend personally. Okay. I don't talk about the textile waste, but I give you a figure. Tell you why Taiwan have to face the textile to textile circularity. You know, as this figure, we lots of the textile waste generate, but only around 12% are recycled. But 12% recycle, only 1% will make the land to be textile, used for textile. Okay, skip this. And this figure I show you, Taiwan is very strong in synthetic fiber, especially we use the bottle, the waste bottle. We collect the waste bottle, let it be recycled, we call RPD chip. And most of the, maybe 10 years ago, Taiwan's the RPD chips is for produce the RPD fiber. But now, you know, there's a serious problem because the regulation, you know, the plastic bottle and the package, they has this similar rule. So that means our production of the recycled polyester chip is not for recycled fiber anymore. As you know, Taiwan is strong for synthetic fiber garment from the synthetic recycled polyester. But then if we show down the material, we cannot use the recycled polyester. Now in next table we should use. And we cannot order to textile, right? So we have to develop a textile to textile. We must recycle unused, discarded garment and make them to fiber. But if we use the unused clothes, what should we do? Actually, do you know DBD? No. DB is important because Taiwan is export. Most of our textile are export. If we some brand, especially in the EU, they need next year, 2027, we need to provide a DBD QR code on our products. One of the most important QR code information is what did you use your fiber? Where is your fibers from? We have to put exactly the information on the QR code. So we can see this figure. It's a normal textile recycle, but we can find there's three parts of the recycling material. But when you use the recycled material, I think most of them have this question. Where did they come from? I don't know. For example, when we use textile to textile, but in Taiwan, actually, some of the unused or discarded clothes is from overseas, not from Taiwan. So Taiwan's community has wondered where I am from. And then the most important is when we use the recycled materials, do you see these materials up to standard? So are they traceable? It's most important is traceable because the DDT, the data must be traceable. So if you use all the measure to if we will use all the measure to sorting unused clothes, the most question is the mixed fiber. Most of the Taiwan's the young fiber or fiber are blended. For example, cotton with polyester, rayon with cotton, or polyester with wool. So the how? Okay. So I can just use it. So that's you can change. So the manual sorting is really have a problem. And if we just we cannot recognize the material blend ratio. Even someone cannot distinguish the rayon, rainy, cotton, or even cotton. Now you know the polyester, the touch, the handle is really similar to cotton. So if you use manual sorting, there's lots of question. That means if we separate all the clothes, but the data has something wrong. Thank you. Okay, thank you. I said, so the bottleneck of the manual sorting, I think, is here. Limited accuracy. Blend, special blend is difficult to identify. Low speed, labor intensive, such that. And especially, we need to put the data to DBP file, DB cloud. If we use the manual sorting, the input data is fairly labor intensive. Next. Okay, so we need okay, next. Okay. So if we use AI sorting, you can know this machine can upload the data immediately. Also, you don't worry about the data missing. If you use this AI sorting machine, the fiber, the yarn and fabric, they can produce a QR code for this Oh, so you know if you use AI sorting, have accuracy for fiber composition, high speed, real time, stable, reproducible, performance, high scalable, and then for such like that. That means the data is complete and freely traceable and trustable. Okay. Our AI-based sorting connects three components. One is sensing. We use NIA. Next is AI. AI, of course, is a model. It's a complex model. So we use AI learning or machine learning. But we can provide we can from to the automatic separation. Okay, separate. For example, cotton to here, polyester to here, nylon. We can now professors here they can separate at least I think eight different kind of fiber, especially the blend ratio. Blend ratio. For example, 65 polyester with 35 cotton, something like that. They can separate. If you the clothes is made from 80% cotton, 20% polyester, it's okay. You can show on the data. So I show you the machine. And if this is not a theoretical or pilot plan, now in Taiwan, TTR has built for this demonstration set. They are as sorting, shading, the most important separation and recovery, polyester decoloration. These two, please, next, please. This part is for mechanical recycling use, and this part is for chemical recycling use. Also, this is very easy, and now we have another pilot plan. They have collaborated with a big cotton spinning mill. So they use the AI sorting, shading, and that can become really the young from here. And this is for chemical fiber use. I don't talk about this. If you are interested, we can talk about this later. I'll give you a video. It's a new machine, and the most important, this machine is GS certificate. That means the output material is certified by can approved by GIS. So no problem about the quality.
Professor Park, do you mean that the sorting by this machine is certified by GIS?
Yes.
Recycle?
Because you need to tell them how many old clothes, the unused clothes, and make them to deliver and check the amount is the same.
So they certify the machine?
Yeah. For this head is 30% pre-consumer wool and 35 pre-consumer wool and 30% post-consumer wool garment and 35 recycled polyester. I can tell you who uses this, but there is a French brand. French brand uses this. Oh, it's a famous brand, French brand. This head will be sold. So if you don't have this use AI sorting, they cannot make sure the composition is exactly is right or wrong. I give you a video, but it's the older one. Oh, it's the old machine, but it's really used in Taiwan.
The company has developed an intelligent sorting system that utilizes near-infrared (NIR) spectroscopy for fast and non-contact identification of textile materials and AI machine learning for high accuracy. This technology assists textile recycling operators in precise material classification and provides high-quality waste textiles as feedstock for chemical fiber factories, closing the loop in textile circular economy. The accuracy of the sorting system has been recognized by professional organizations and has been successfully tested in production processes at chemical fiber factories. Paid technology aims to establish a green textile circular ecosystem by integrating the textile industry supply chain to contribute to achieve the goals of net zero carbon emission.
Okay, it's my presentation. Thank you. If you have any question, we'll discuss later. Thank you, everyone.
Sawadika. Good afternoon, everyone. It's my great honor to be here today. My name is Shang Bohan from Welcome Enterprise in Taiwan, a manufacturer of a natural fiber extraction machine. My English is not perfect, but I will try my best to present clearly. Today, I would like to share our experience as a manufacturer working on the industrialization of low-carbon natural fiber and how agricultural waste can become sustainable material for the global textile industry. The global textile industry is under pressure to become more sustainable. Governments are introducing policies to reduce carbon emissions and promote circular materials. For example, the European Green Deal encouraged the textile industry to move toward sustainability. At the same time, organizations such as Textile Exchange are promoting carbon reduction across global supply chains. This is increasing the demand for sustainable and low-carbon materials. As a result, global brands are also making strong commitment to sustainable materials. Many companies aim to use more recycled or sustainable material in coming years. They have announced clear sustainability targets. This creates strong opportunity for sustainable natural fiber materials. Around the world, agriculture produces large amounts of residues. For example, pineapple leaves, and banana stems, most of these materials are not fully used today. That represents a huge opportunity for sustainable natural fibers. However, turning these residues into high-quality fibers still faces many challenges. Agricultural residues have great potential value. They can be converted into natural fiber, bio-based materials, textile raw materials, and composite materials. However, today many agricultural residues are still burnt, discarded, or used for low-value purposes. This causes air pollution, carbon emissions, and resource waste. Therefore, turning agricultural waste into valuable materials creates an important opportunity for the circular bioeconomy. Taiwan is a good agricultural resource organization. Taiwan produced large amounts of pineapple leaves and banana stems in the past. These materials were often discarded. Today, they are being explored as sustainable natural fiber resource. However, turning these residues into high-quality fibers still requires sustainable technologies. Although agricultural residues have a great potential, natural fibers process still face several problems. Traditional processes usually require multiple steps, which reduce efficiency. This challenge limits the production of natural fibers. To address this challenge, we developed natural fiber extraction machinery at Wellburn Enterprise. Wellburn 3-in-1 fiber extraction system that integrates extraction, cleaning, and brushing in one process. It can process multiple plant fiber. Our goal is to transform agricultural residue into low-carbon materials. 3-in-1 system integrates 3 processes into one machine. The integrated system allows us to achieve high-quality fibers in a single process. It shows the difference in fiber quality. With conventional process, fiber may be damaged, broken, and often contain residues and impurities. The quality also can be uneven. With our 3 systems, the fibers are clearer and more consistent. It improves the overall fiber quality. Our system supports multiple types of natural fibers. It includes pineapple leaves, banana stem, sisal jute, rami. It extracts from different plant materials and produce useful natural fibers. This fiber extraction system has been applied in several regions around the world. It can support multiple natural fibers across different regions. In addition to fiber extraction technology, we are also exploring solutions to improve pineapple leaf collection efficiency. Currently, pineapple leaves are mainly collected manually in Taiwan, which is labor intensive. Therefore, we are developing mechanical tools for pineapple leaf collection. This could increase collection efficiency, reduce labor intensity, and improve the supply raw materials for natural fiber extraction. Finally, this photo from our customer, one for our company. It shows agricultural residues can become real products, from pineapple leaves to natural fiber textile, and finally to sustainable clothing. Thank you for your listening.
presentation will be from KAPI. Dr. Valorization.
Good afternoon, everyone. Today I will present just like a research program, one research program in our institute. This is about pineapple to make it as a natural fiber research, just like a coincidence, just like Mr. Sam just said. Our institute is cooperated with the textile science faculties of agro-industry. And the means of the research is focused on the research and development in natural fiber. Just like we want to move from the traditional agricultural to the high performance industrial applications, such as textile and another industry, just like cosmetic and something like that. Our mission, our objective of this project is just like want to transition toward circular economy through the comprehensive and zero waste utilization of agricultural by-products. The background of the project is we have just like problems of environments, because we have pineapple leaf in Thailand, just like around 40,000 tons that live in the agricultural fields. Some of them falls back in the fields, and another burn in the open air. That makes some hazardous PM2.5 pollution in Thailand. This research program consists of the many sub-project research. One of the research projects is just like a try to produce the automatic decorations pineapple leaf, just like maybe different techniques, but the same purpose. Just like we want to develop the custom automated machine system to upscale pineapple leaf fibers extraction. And our results is maybe not satisfied yet, but we try to improve the new versions of the machine, and maybe we can join together and exchange the data to develop is just like not we aim is not only the small machine, but we aim to produce the industrial scale machines. And another project is just like about the material science. We also collect the data as a database mapping morphologies, chemical compositions of the various pineapple leaf that grow across the Thailand. And this project is expected result is a consistent, high quality fiber extraction that's ready for commercial and industrial scale. And another project is just like use the fiber from the first project to transform the pineapple fiber into the commercial eco products. In this project, we use the materials to do many products, just like thermal and sound installations, by blend with the PET, just like recycled PET that we use, and the result is quite good for sound installation. And another project is use just like utilize the short fibers and peel waste in a traditional paper making process to create the sustainable packaging and containers. We try to use the waste from the textile process to produce the packaging. And the last one is just like spinning in textiles. And we also try to use the advanced sustainable fiber techniques, just like regenerated cellulose. We try to produce the lyocell fiber direct from the dissolving out of pineapple industrial waste, and also use the stem of the and rhizome of the pineapple to extract the enzymes and use it in the premium cosmetic and dietary supplements and high-grade animal feed. Okay, this is all of this research program that I introduced for you today. Thank you.
Next will be Dr. Ramsna. Okay. Please welcome Dr. Ramsna.
As I show you why we interest about the result. So normally, as you know, Thailand is exported of cassava starch, and the waste from the field of tapioca is leaf. So the one kind that you want to use leaf from tapioca starch that to be feed for the silk. It's one type of silk is a white silk that we want. That why Kasisa University interest about real silk. So I'm researcher that I work following the previous researcher that because we are Kasisa University have excellent center of smart silk that located in Kasisa University, Kamphaeng San. is upstream to produce the egg and produce egg to distribute to the farmer. Okay. Why silk is different from silk, mulberry silk. So the cycle is longer than mulberry silk, but it can be strengthened easily to feed them. And as you know, after the farmer that culture the tapioca plant, the wife can have time to take time to feed them and to culture them. That's why we want to distribute the method how to do for the GAP grab to produce the cocoon silk, cocoon during silk that to give higher potential for to do for the smart textile, and also that just only cocoon just only 10%, but in the rest is a pupa that allow 90% that can give more functional protein or functional oil that's produced for the food, supplement food, and also for the cosmetic. Okay, this is like that show our works in Ksesar University, also in part of KPI, and also in part of Excellence Center of Smart Silk. So we do for the machine, that's for the farmer to do for cutting the cocoon, and also for the machine to do for the opening the cocoon after do for the degumming, and also machine to do for the cutting. That we install them at the Conget University, Conget province that Metongler. Last time we visit them and we do for that during the last month. Also the machine for spinning too. Okay. As if compare the property of the silk, the silk fiber, so iris silk it should be more elastic compared to the mulberry silk, but the iris silk is thicker than mulberry silk, but it gives more thermal property compared to the mulberry silk, and also easily to do for in the knitting and easily for the rendering in the machine. No need to do for the extra washing. And how about the chemical properties? So that alanine and more than silk more than mulberry silk, and that's why the component of them it gives the higher extension compared to the mulberry silk. And also for the silicene, they give ricin and histidine more than. That's why it should be good for the cosmetic. Also for all the components of the cocoon, early cocoon that we give for the fibrine, that's good for the textile, not in general textile, but we can advance for the medical or for the engineering scaffold. And also the silicene also is a high value cosmetic. The other part is special because they are 90% weight of cocoon that remain in the pupa that remain in the cocoon, that it should be high protein superfood, and also some other special such as oil and protein. And also it weighs the shield chitin that now we in the international paper that concentrate to extract them and do for the packaging. This for general that we do for the innovation about textile, that should be first it should be eco-friendly processing, that the treatment, natural dyeing, and finishing with the method that can give a more green method, and also have a functional, for example, to the like they have their special antibacterial property of the dairy fiber that it can be good to do like a multi-layer fiber, filter mask, and also the other method like to dissolve them and regenerate and spin again. On the other part, also they do for the medical fields, for example, films, scaffold, hydrogel, and also fiber. The other one that we have collaborated with this that the Korea guy company want to use for the cosmetic. The other one part also normally we decomming them with the alkali, but the other method that for to do a green, for example, we extract with the enzyme extraction that can be good property for the fiber and also the silicene that it remain. Even it's just only 10%, but it can be good for the other part for the customer, cosmetic, for the food packaging and also for the biomedical. The other part is food part that we give that there's good protein and also fat. Is compared to the mulberry, it should be give protein higher than and especially for essential amino acid. And also fat, even it give the less amount compared to mulberry, but it give the unsaturated fat better than mulberry crupa. Also, we do for the food, also for the cereal, for the ether, and also this for next in future part of textile that we use for the functional fabric and also multi-layer member. Okay, that is the percentage of protein compared with the cocoon, with the pupa and also with the worm. Yes, and this show the farmer that the culture usually that can be distributed in the northern part and also eastern part, that we can give information and techniques transfer to culture them to be the GAP, and they will give the high quality of cocoon that give maybe bigger than one, and also the quality for the pupa that can be good for the functional food and also for the other parts of cosmetic. Thank you. We can discuss it. Okay, Dr. Janwa. There's a presentation about the
So, good afternoon, everyone. Today, I'm going to talk about extract compounds and also overall of special research unit in bioactive compounds and product development. First of all, I would like to first of all, let me introduce our special research unit on healthcare products and cosmetics. Mostly we have been working on bioactive compounds and product development. So for our expertise, we have like 5 expertise, including extraction of natural active compounds, structural modification and encapsulation, development of functional ingredients, development of beauty products, and development of healthy products. So, the scale of our research also starts with research and development, laboratory scale, pilot plant scale, and industrial scale. This also together with our partner. So, for natural fluorine extraction pilot plant, these mostly we set up this pilot plant for to support fluorine companies on the expansion of fluorine extraction capacity from velvet raw materials to be research and development center for natural fluorine production to transform agricultural products into innovative products in food fluorine industry, to be learning center for entrepreneurs, and also to strengthen the linkage between academic and government researcher and also private sector. So, for our natural fluorine extraction pilot plant, we have like overall, including 3 parts, including multifunction extraction unit. This is for extraction with organic solvents, and the next one is supercritical fluid extraction. This is for extraction without organic solvent, and we use supercritical carbon dioxide for extraction. And the last one is molecular distillation. This is for purify the extract. So then let's move to bioactive compounds and product development. So mostly we have been working on bioactive compounds from plants, herbs, insects, microorganisms, and agricultural waste. So let's start with silk cocoon. As Dr. Ransma also mentioned already about this. We have chemical active compounds like fibrin hydrolysate. This is in amino acid form. These process skin and hair softening and nourishing. Also have like UV protection property. This also we can use this to apply in like protein jelly in food or drinks, and also we also can use for synthetic fiber coating. This also can enhance the appearance and give it like still like look. And another one, serine hydrolysate. This I think everyone knows as the silk glue protein. So this contain 18 amino acids like our skin and nail. This can has like skin nourishing, UV protection, antioxidant and antimicrobial property, and also wound healing properties. So we not only have extract, we also have encapsulated form. This is our trade name, liposil. This is encapsulated serine hydrolysate. So after encapsulation, it also can increase stability and skin permeability. And also we also have laboratory tests. And this is an example of the products. This is also available in our institute. For example, body lotion, hand cream, and lip balm. This for skin nourishing, like moisturizer. the next one. This is pineapple rhizome. As we know, pineapple rhizome contain high amount of bromelain enzyme. So we have both in purified and also crude form. So these contain anti-inflammatory and antioxidant properties and also exfoliating and anti-aging properties. And this is an example of the product that this already finished. We cooperate with company like skin booster serum. This for anti-aging and also make your skin look younger. So the next one is mangosteen peel. Mangosteen peel, we know it contains xanthone and tannin with process. For xanthone we know is an anti-inflammatory, antioxidant, and also antimicrobial properties. And for tannin, we know it acts like wound healing agent. So our product, we have acne spot gel. It's also available for selling. And the next one, purple rice. We have hydrolyzed. We have hydrolyzed rice bran protein. This is the waste from rice bran oil extraction. These compound contain processed antioxidant, anti-aging. Is act like so for for the proposed rice extract, we have hydrolyzed rice bran protein. This is waste from rice bran oil extraction. This process antioxidant, anti-aging. It works like collagen simulator. Also skin nourishing, and these are mostly for skin and hair. And we also have available products, sleeping cream. If you're interested for shopping, I invite you to visit our institute. So the next one is coffee ground extract. we extracted with ethanol. This extract contains caffeine and chloric acid. That's we know chloric acid also has antioxidant and anti-inflammatory effect. So the extract can reduce wrinkles and acne, and also can use as skin foaming agent. So the coffee ground extract, we also have encapsulation form. The trade name is nano capsule coffee. After encapsulation with polylactic acid, it also could increase stability, solubility, and skin permeability. Okay. Okay, so let's continue. We also have sweeping cream available. So okay. So not only encapsulated extract, we also have products available. Actually we have more, but it's just for example. We have body lotion, face serum, and also body scrub. This is mostly for skin foaming. Okay. The next one, andrographis extract. This we use in shampoo, shower cream, and soap. This the andrographis extract possess like antimicrobial agent. So this soap and shampoo also can inhibit bacteria and more on skin and scalp. This also available. And the next one, ply. I think Thai people I think know, but I'm not sure if you know. It look like similar to ginger. It contains curcuminoids and phenolic compounds. And this mostly possess anti-inflammatory. We apply in this is our available product, Siam Ply Yellow Oil. This product can reduce aches and pain. Mostly in spa, they also use as like massage oil, and also and also can add like refreshing. For example, when we feel tired or sleepy, we also can use app inhale. And this one, persimmon and Bengal currant extract. These we use in gummy jelly. This is example of our research prototype. This can lower blood sugar level for diabetes. And this one, Hogan grass extract. This extract has antimicrobial and antioxidant properties, and we use in toothpaste. These toothpaste have special property. It can reduce bad breath and also gum hair. This also we also work for company and also available to sell in. It's not sell in our institute because these are under license with company already. As I remember, the owner of this product also the actor of Thailand, On Sarawut. Okay, this must be the last one. Actually, we have more, but I just give you for example. This one is body lotion. We have like tomato extract. So this body lotion contain tomato extract like lycopene, vitamin A, vitamin C, and this also available for selling. And actually, this also popular among our customers. Okay, so. Okay, so as we know, the research about natural about extract from bioactive compounds and product is is growing, has been growing every year. So I think this is a good chance for both like farmer, researcher, entrepreneur, and also company for this. So thank you for your attention.
Professor Pacharin ได้ขออนุญาตนำเสนอเทคโนโลยีต่างๆจะได้เห็นว่าอาจจะปัจจัยอาจจะเป็นการใช้ได้
Good afternoon, everyone. Today I would like to present our research project about the key technology and innovation for 3D printing technology by using the raw material as a potential for value-added low-carbon material. Yes. I have been corporate working with the professor, associate professor Dr. นัฐการ พงศ์ศรีพันธ์ from the Department of Material Science Engineering, Faculty of Engineering and Industrial Technology, Silpakorn University, for almost 20 years on the biopolymer and composite. Our work has been to study and to work on the theoretic material derived from agricultural and agro-industrial residue. This topic is about we have been explored in many waste material from the start of the livestock with plenty of silicon dioxide and the pineapple leaf fiber, coconut fiber, coffee ground, also beverage spent ground such as the beer and also the wood from furniture manufacturing, as well as extract the calcium carbonate from eggshell and make it as a calcium oxide. And also another we also work on another inorganic filler as well, but because of today we are only focused on the theoretic material. We found that there is a strong potential to use the theoretic material for the reinforcement for the bio-based composite. And then we have do many research on the plastic product itself. And recently, about 3 years from ago, we have a PhD student who made the 3D we get more PhD students from the industrial, like they have been experienced in industrial for about 5 and 10 years, and they come back to study PhD in our department. One is doing on the 3D printing machinery, another one is working on the 3D formulation of the filament. That's why we today I talk about the innovation on the 3D printing bio-based. First of all, I have to give you the background of there are many type of additive manufacturing, but anyway, for the popular one now is fused deposition modeling. We call it FDM, which is used as the filament, and then using the thermal process to make it come out as the material. This is some example that we incorporated using many types of theoretic fiber. Okay. Yes. We got the theoretic waste material from the farmer. That is we cooperate, and then we know the source and also the production. I mean the quality of the production product. And then we sometimes because we also got we have the equipment plastic processing equipment in our department. So we use some kind of the extrusion process to compound the fiber with the polymer blend. For example, like PLA and PBAT polymer blend to try to find the right formulation for each material. And this is on the left-hand side. On the left-hand side is we use the coffee ground for the bio blend and then produce as the filament and use the 3D printing to make it in different kind of shape. On the right-hand side, this is one example that we not only do the engineering part, but we try to make it fashionable, like a part of the fashionable one. This is an example we use the formulation, especially to make the soft button designed for children clothing. So the mean is if we compare with the traditional button for the kids, it's kind of hard, and sometimes it's when the children play in the playground, and sometimes they broke their button, and sometimes they got some kind of broken button that may harm the skin of the children. So we kind of to produce the formulation to make it small as a soft button, and use the 3D printing to produce the soft button. I mean, it has to be precise hole. Yes, that's why we have to do some other research as well, try to make the hole more precise dimension. because otherwise in the 3D dimension, 3D printing, the advantage of the 3D printing is like that because of the shrinkage problem and the warpage problem. I mean, after produce the product, the size or the dimensions may be like not meet of the standard. So we have to try to find many ways to formulate the right formulation to produce for the filament. This is an example of doing the egg-shelled calcium oxide that we have to extract the calcium carbonate and then make it as a calcium oxide by thermal process, and then we formulate with the polymer blend to make it a filament, and then we use the in-house 3D printing machine that we brought up, we built up by our PhD student, and then we kind of try to make the adjustment and find the simulation. You can see that this is the kind of the example of this crystal, which it has to be the precise dimension, because otherwise it will not grow properly. And also this is kind of the another type that we try to adjust our formulation of the polymer blend to make it more like a useful and correct dimension. Another thing which is not the 3D printing, but it's kind of we try to utilize the agro-industrial residue. It's not the same as your research. But we use the waste from the mango steel peel because, and also the by-products, which is called the ginger leaf. We didn't use it directly for the 3D printing product, but we use it as a template to do the green synthesis by convert the zinc compound like the zinc nitrate, also zinc acetate or whatever zinc compounding. Try to convert it into the zinc oxide. By using different extraction of plant waste, it produces a different kind of the template. For example, if we control the condition, we can get the zinc oxide in the shape of polygon, and if we make it like a green synthesis in another condition, we can produce the zinc oxide into like a middle form. The two different forms of the zinc oxide provide different antibiotic property. Means it's believed that many researchers show that there is some kind of the research, many other research show that for the needle like zinc oxide provide better antibacterial property. So we use it and incorporate with another PhD student who doing the dentist for their degree. We make it and put the zinc oxide into the biomaterial and make it a template for teeth. Different teeth, but using the 3D printing method to make it as a model to before adjust the right shape of the teeth to the patient. Another one that we use the 3D printing as the replica for the textile inspired design. That to make the replica before that, to make the different shape of the plastic 3D printing as a fabric. We need to put like a drawing in the CAD/CAM program and then transport the CAD/CAM design into the computer and then generate using the 3D printing to make the fabric. We use another type of the replication because use the lower temperature of plastic and then we put it as on the, we draw the 3D printing as on top of the prototype fabric and then replicate it into another style and try to make more texture to the fabric itself. Okay, I think this is all from our research group right now at Singapore University, and we hope that some of the pioneer research of our group will and do some cooperation with other researchers here, and we hope that the innovation for the low carbon material and also the low saver energy process 3D printing will be the future for using the bio-based material here in Thailand. Thank you very much.
Next will be presentation for first discussion. May I invite Ajahn Pacharin, and after that we will have a first discussion about how to utilize the technology.
Good afternoon, everyone. Okay, the topic today for my presentation is theory for agricultural residues for low carbon materials.
some of you familiar with the zeolite? Not much. Okay. I will overview about the zeolite a little bit. Zeolite is the crystallized aluminosilicate with the 3D framework, and they have the property of the porous, and they can have the property of the high cation exchange capacity. And the zeolite can hydrate and dehydrate with no losing their structure. And that is the main property of this zeolite. They can trap the nutrients inside the pore because that is the pore structure of the zeolite. And there are many types of the zeolite, like the natural and synthetic zeolites. And this for the agricultural residue. So we can try to use the agricultural residue to convert to the zeolite. And how many types of the zeolite? There are many, like more than 200 types of zeolites nowadays. And there are 3 types of the zeolite. They can classify by the pore size: small, medium, and large pore size. And for the circular bioeconomy, we can use the log agricultural material to convert for the silica source, and then silica source can be synthesized to the zeolite because the zeolite can come from silica source and alumina source. And we can use in our research, we use the bark ash and rice husks, and you can use many kind of the agricultural residue like the bamboo, pineapple, and something for we can extract the silica from that material, and you can use that one for the capture of the CO2 capture also. And for the benefit of the zeolite, we can select the zeolite that we can use for many applications, and we can use for the low energy synthesis to get the zeolite. This is for the example of the silica source. We can use bark ash, rice husk ash, waste grass, fly ash, and something for the silica. And then we can use the alumina from the natural also. And then we mix together for the step of the synthesis of the zeolite. So we can get the zeolite, many types of zeolite, and we can control the condition to create the pore that we use. And this is the main property of the zeolite. We can use the benefit of the molecular sieve of the zeolite because the zeolite can allows only molecules of the specific size can pass through the pore and can trap the bigger one. And then another one, we can use the zeolite can separate the substance because the identical chemical formula, and we can have the many structure of the shape of the zeolite. We can use this one for separation of the isomers. And this is one of the property that we can use zeolite. The zeolite can have the benefit of the high sensitivity protection of the moisture. Because the zeolite, they have many type of the zeolite. We can select the high silica and alumina, or low silica and alumina. So we can shape the different type of the zeolite. For example, if we would like to use for the moisture sensitive, we can use the high silicon and aluminum ratio of the zeolite because the zeolite is a crystallized aluminosilicate, and zeolite has the high water binding capacity without losing their property structures, and they also have the concentration to increase the extract concentration with the closed loop system. And also they can use for the medical. We can use the silica for drug delivery because the pore size structure inside they can encap, like the Dr. Jarukon mentioned that encapsulation. We can use the silica instead of the stacylin you use the saline encapsulation, that is the benefit for the antibacterial, antioxidant. Zeolite can be this one also. And we can use for the cosmetic because the benefit of the zeolite, we can use that like the UV protection and something that we can apply for that area. There are many types of the application that we already mentioned. And also the one benefit of the zeolite, we can control the odor. Maybe you can use like in the application of the chemical factory to reduce the emission, air emission, VOC, CO2 emission, or if you use in the application of the animal feed, you can like reduce the odor of the waste of the animal, right? And also for the gas absorption, because the benefit of the zeolite is the pore size, different of the pore size. And there are many types of the zeolite. This one is the clinothiolite. That is one of the zeolite. And this one we can show this one for the food production and agriculture. We can use the zeolite to put in the soil, and the plant can grow easily and can grow up better than this one. We can use for the animal health, aquaculture, because when we put the zeolite in the water, we can treat the wastewater also, because we have the benefit of the like the positive and negative charge, and we can measure the zeta potential. This one characterization. We can measure this one that can coagulation of the sample in the water. And this one is one of the application for the medical. We can use for the wound healing and drug delivery. Also for the like the nano material, we in our laboratory can use the nano material to drug delivery also, like the silica, iron oxide material also. And the zeolite is one of the benefit that one. And this is the summary of the textile industry. You can use like in the supply chain in the beginning for like the bleaching and dyeing for the textile industry, for wastewater treatment, and in the dyeing you can use for like the ion exchange. I think the textile industry have like the problem about the calcium ion or not. I'm not sure. We can use this one for exchange because the zeolite have the sodium ion in the pore structure, and we can exchange the calcium inside in the pore also. And many type of the ion exchange we can use. And this one for the summary of this textile industry. For you can use like the UV shielding and liquid discharge also. And this one for the insects, because the first time I think the protein insect come for this forum, but today is not, right? So yes, so I think we can pass this one. Yes, you can use this one for the control moisture also. And this is the summary for all of this one. We use the agricultural residue for the synthesis of the zeolite, and there are many types of the zeolite for the pore structure, and we can apply for many types of your applications. Okay, yes, thank you for your attention, and we can share the experience more for the forums. Thank you.
Before start first round of discussion, may I just very brief introduction of the hub of knowledge for low carbon material, and may I speak in Thai because I already presented to you yesterday. It's the same information. จะได้อธิบายได้ชัดนะคะ หลายท่านอาจจะเคยได้ทราบอยู่แล้วเพราะว่าเคยเรียนสัมภาษณ์หรือว่าขอข้อมูลมาก่อนหน้านี้นะคะตัวโครงการนี้ค่ะเป็นโครงการที่ได้ทุนจากสภาวิจัยแห่งชาติวช.ของปีที่แล้วแล้วก็ยาวมาถึงปีนี้นะคะซึ่งจริงๆโครงการนี้ต้องเล่าว่ามันไม่ได้เป็นการพัฒนาแมททีเรียลหรือเทคโนโลยีหรืออินโนเวชันแต่เป็นโครงการที่เน้นเรื่องการเชื่อมโยง
สร้างเครือข่ายของนักวิจัยผู้เชี่ยวชาญนะคะแต่อยู่ในคำว่า low carbon material แต่ทีนี้ปีแรกนะคะเนื่องจากมันเป็นปีแรกแล้วก็ถ้าดูจากนักวิจัยหรือพื้นฐานของความเชี่ยวชาญของคนที่อยู่ในเครือข่ายก็จะมาทางวัสดุจากการเกษตรนะคะทีนี้ก็จากที่ทำงานมาแล้วก็นำเสนอทางผู้ทรงคุณวุฒิที่วช.ก็เลยโฟกัสไปที่วัสดุจากภาคการเกษตรแล้วก็โฟกัสลงไปอีกว่าที่จะเป็นวัสดุเหลือใช้หรือเหลือทิ้ง Agricultural Waste Agricultural Residues รวมถึง By-products นะคะที่มาจากภาคการเกษตรซึ่งอันนี้ค่ะก็ส่วนหนึ่งก็มาจากการที่นำเสนอความก้าวหน้ากับทางวช.ก็บอกว่าเนื่องจากเวลามันไม่ได้มากสำหรับปีแรกแต่เรียนว่าทุนตัวนี้ค่ะปกติแต่ละศูนย์ก็จะได้ต่อเนื่องประมาณ 3-5 ปีแล้วแต่ผู้ทรงพิจารณาเมื่อปิดโครงการนะคะก็ไม่แน่ใจว่าได้ต่อหรือเปล่าแต่ถ้าได้ต่อก็จะมีโอกาสขยายผลต่อไปก็ส่วนมากก็มักจะได้นะถ้าศูนย์อื่นนะคะก็เว้นทำงานไม่ดีอันนี้ก็นะคะแต่ว่าตรงนี้ค่ะกรรมการก็บอกว่าก็อยากให้เลือกอันที่เป็นแบบกรณีศึกษาที่เราเนี่ยมีเพราะว่าความพร้อมถึงได้นำมาสู่พืชที่คัดเลือกขึ้นมาว่าน่าจะมองเรียนตัวเวสจากสับปะรดหรือทางด้านของซิลหรือจะลงมาที่อิริซิลซึ่งเป็นไหมป่านะคะเพราะฉะนั้นศูนย์ตัวนี้ก็เลยโฟกัสลงมาที่ตัวกรณีศึกษารวมถึงชุมชนที่จะลงพื้นที่ในการเก็บข้อมูลต่างๆแล้วก็เครือข่ายนักวิจัยก็ค่อนข้างเทมาลักษณะนี้นะคะแต่ทีนี้ถ้านิดนึงว่าตรงศูนย์ทำอะไรนะคะหนึ่งก็คือสร้างตัวเครือข่าย2นะคะก็จะพัฒนาไปเป็นเว็บแอปพลิเคชันหรือเว็บไซต์ซึ่งก็ใช้ชื่อนี้เลย www.low-carbon-org ตอนนี้ก็เอาขึ้นใช้จริงแล้วแต่ยังไม่ complete นะคะเพราะฉะนั้นในนี้สิ่งที่ทำก็คือจะมีตัวฐานข้อมูลงานวิจัยที่เกี่ยวข้องกับ low carbon material จากภาคการเกษตรเดี๋ยวโชว์ให้ดูอีกทีค่ะว่างานวิจัยทำตัว landscape ออกมาแบบไหนนะคะอันที่2ก็คือจะเป็นฐานนักวิจัยผู้เชี่ยวชาญนะคะ11 สาขาซึ่งก็มาจากมหาวิทยาลัยต่างๆมาจากสถาบันวิจัยที่อยู่ภายใต้มหาวิทยาลัยสถาบันวิจัยอย่างสวทช. นาโนเทค M-Tech อย่างนี้ก็อยู่ด้วยหมดนะคะแล้วก็จากภาครัฐจากหน่วยงานซัพพอร์ตนะคะต่างๆก็อยู่ร่วมกันตอนนี้มีประมาณ81ท่านแล้วค่ะสมาชิกค่อนข้างเยอะอยู่นะคะแล้วก็นอกเหนือจากฐานนักวิจัยก็จะมีฐานตัวหน่วยงานนะคะเพราะฉะนั้นก็จะบอกเป็น one page profile ของนักวิจัยคนนั้น one page profile ของหน่วยงานวิจัยนั้นๆนะคะว่ามีความโดดเด่นนะคะยังไงบ้างนะคะในบริบทของวัสดุจากภาคการเกษตรนะคะเหมือนกับว่าเมื่อกี้เห็นท่านตรงหน่วยงานนี้ก็ทำไบโอชายกตัวอย่างนะคะหน่วยงานนี้ก็ทำไบโอชาแล้วเกษตรที่ทำไบโอชากับ M-Tech ที่ทำไบโอชาความโดดเด่นต่างกันยังไงวันเพจโปรไฟล์ตรงนี้กำลังพยายามรวบรวมข้อมูลที่จะเอาคำสั้นๆหรือ1ประโยคที่เข้าไปดูแล้วมันเห็นด้านที่แบบเน้นของแต่ละหน่วยงานให้ชัดขึ้นนะคะมันมีก็ยอมรับในความซับซ้อนของงานวิจัยที่เราทำกันใช่ไหมคะมันก็มีความซับซ้อนหลายอย่างแต่ว่ามันก็มีความโดดเด่นหรือการที่จะชูเนี่ยในแอเรียที่ต่างกันระดับหนึ่งนะคะอีกอันนึงก็คือจะเป็นตัวฐานงานวิจัยนะคะซึ่งเวลานี้ค่ะตัวฐานงานวิจัยอันนี้เครือข่ายนะคะขอโทษขึ้นไหมคะออกขึ้นนะคะเครือข่ายจะเห็นว่า80กว่าท่านอยู่ตอนนี้นะคะวงในก็คือตัวนักวิจัยวงนอกถัดมาก็จะเป็นหน่วยงานซัพพอร์ตต่างๆแล้ววงนอกสุดนะคะ outside we will be supportive organization we have like 81 member right now in our hub and can be classified in 11 groups ประมาณ11 สาขาซึ่งอันนี้ from all the supply chains we have not only material science we have a supply chain management we have LCA eco design we have a supply chain data mining data management in all area for total supply chain อันนี้คือหน้าตาเว็บไซต์ตอนนี้นะคะแต่ยังไม่ complete แต่เข้าได้แล้วค่ะก็มุ่งในเรื่องให้ข้อมูลเรื่องเครือข่ายนักวิจัยให้ข้อมูลเรื่องงานวิจัยให้ข้อมูลเรื่องของการตรวจสอบย้อนกลับนะคะอันนี้เป็นอันที่อยากจะพัฒนาให้เกิดขึ้นแล้วเป็นประโยชน์เพื่อการใช้จริงเดี๋ยวจะเป็นคำถามที่2ที่จะขอโฟกัสกลุ่มนะคะว่า traceability เนี่ยทำแล้วภาคอุตสาหกรรมหรือภาคธุรกิจต้องการไหมมันจะไปเป็นประโยชน์ยังไงอะค่ะคือทำแพลตฟอร์มมาอันนี้อันที่2แล้วอะค่ะก็รู้สึกผิดอยู่ว่า อันแรกมันความเคลื่อนไหวมันไม่ค่อยมีค่ะก็อยากจะทำให้ข้อมูลที่ทำเนี่ยมันได้ใช้ประโยชน์เล็กๆก็ยังดีค่ะไม่มุมใดมุมหนึ่งนะคะหรือต่อยอดไปในการ รับรองอะไรบางอย่างหรือเป็นประโยชน์กับภาคการเกษตรแล้วก็เหนืออื่นใดก็คือมันเกิดตลาดนะคะอย่างเนี้ยมันจะดีมากๆเลยนะคะก็เลยพยายามที่จะขับเคลื่อนตรงนี้ให้ขยายผลได้นะคะแล้วก็ศูนย์ก็ทำหน้าที่จัดกิจกรรมเชิงวิชาการต่างๆอย่างเช่นการจัดสัมมนาจัดอบรมในพื้นที่ของชุมชนหรือแม้แต่คอนเฟอเรนซ์พอดีเมื่อวานจัด International Conference ไปนะคะก็ต้องขออภัยที่อาจจะไม่ได้กระจายข่าวหรือเรียนเชิญครบทุกท่านนะคะเมื่อวานทางโปรเฟสเซอร์ก็ไปนำเสนอใน International Conference East Pin เมื่อวานนะคะวันนี้ก็ยังมีอยู่วันที่2นะคะแต่พอดีทางศูนย์ไม่ได้ไปมีกิจกรรมอะไรตรงนั้นนะคะเพราะฉะนั้นมันเป็นงานเชิงกิจกรรมมันเป็นงานเชิงสร้างเครือข่ายนะคะตัวงานศูนย์อันนี้นะคะเดี๋ยวขอแค่อีกนิดนึงนะคะเลยให้ดูตรง Research Database นะคะเราขึงออกมาเป็น7 Sector นะคะตอนนี้ในปีแรกนะคะมีอะไรบ้างก็มีพลังงานมีอุตสาหกรรมก่อสร้างมีรถยนต์มี Natural Fiber มี Textile มีวัสดุจากการเกษตรแล้วก็ในกลุ่มเครื่องสำอางนะคะเอาตัวนี้มาทำอะไรหนึ่งก็คือทำฐานงานวิจัยนะคะทำฐานงานวิจัยโดยงานวิจัยตัวนี้เริ่มต้นจากใช้คนทำก่อนคือเข้าไปหาในฐานต่างๆอย่าง Scopus หรือฐานของบ้านเราอย่างนี้นะคะพอออกมาแล้วอะค่ะก็เอาใช้ AI เนี่ยช่วยตรวจสอบย้อนกลับอีกทีหนึ่งนะคะทำคู่กันนะคะหรือตอนนี้ทำไปได้กว่าประมาณ200 กว่ารายการนะคะแต่ว่าอย่างที่เราทราบ AI เนี่ยบางทีก็มั่วอยู่นะคะเพราะเวลาทำอะค่ะอาจารย์ที่ช่วยวันนี้อาจารย์ท่านหนึ่งที่ช่วยเป็นหลักก็คืออาจารย์ธนิตนะคะเอา AI อย่าง Gemini หรือโปรแกรมเดี๋ยวจะนำเสนออีกทีในรอบ2นะคะเข้ามาช่วยในการ classify แบ่งเป็นตามเซกเตอร์ต้นกลางปลายน้ำหรือหางานวิจัยที่มีเรื่อง LCA หรือ property บางอย่างที่เก็บข้อมูลจากสัมภาษณ์เพราะว่าการได้ข้อมูลเรื่อง property ของงานวิจัยเนี่ยจะช่วยในการนำงานวิจัยนั้นไปใช้ประโยชน์ได้ง่ายขึ้นนะคะเพราะฉะนั้นก็พยายามคุยกับอาจารย์เขาว่าให้ช่วยเขียนพร้อมเพื่อสกัดสิ่งเหล่านี้ออกมาแล้วได้กลุ่มงานวิจัยที่ classify ออกมานะคะแต่ก็มีส่วนที่มั่วเยอะค่ะต้องตรวจด้วยคนอีกทีนึงก็มีผู้ช่วยเนี่ยลงไปตรวจอีกทีว่าสิ่งที่ออกมาการสกัดออกมาเป็นพืชหรือการจัดต้นกลางปลายน้ำหรือข้อมูลต่างๆมันถูกต้องไหมต้องทำคู่กันในรอบแรกอะค่ะทำไปกว่า100 รายการก็พบว่าสอดคล้องโดยส่วนใหญ่เพราะฉะนั้นตรงนี้ก็ช่วย verify ได้ว่าการใช้ AI เนี่ยมันทำต่อได้นะคะแล้วก็เดี๋ยวจะทำงานต่อเพื่อให้ฐานตัวนี้มันแข็งแรงยิ่งขึ้นนะคะคุณวัดรู้จักเคยผจญกับแพลตฟอร์มมาแล้วใช่ไหมคะผจญภัยกับแพลตฟอร์มมาแล้วเว็บไซต์นะคะอย่างอันนี้ค่ะก็คือขึงต้นกลางปลายน้ำเราก็จะเห็นพืชต่างๆที่อยู่ในเซกเตอร์อุตสาหกรรมต่างๆนะคะหรืออันนี้ให้โชว์ให้ดูนิดนึงค่ะว่าตัวผลจากการที่หาข้อมูลมาค่ะมันจะเห็นว่าลงไปอยู่ในสกอร์บัสเนี่ยค่อนข้างเยอะเลยนะคะแล้วก็ปีที่ทำงานกันเยอะจะเป็น 2020 หรือปี 2023 ก็จะเห็นว่าโผล่ในสกอร์บัสเนี่ยค่อนข้างมากนะคะ This is from what we collect research work and then use systematic review and also AI technology and we found that in 2020 in Scorbus database highest and also in 2023 and from this categorized from 7 sectors ก็จะเห็นว่า highest number is in construction products that utilize agricultural residue but this is in Thai and in Thai researcher not international ปีนี้หาของคนไทยนะคะเกือบ 2,000 นะคะงานวิจัยทำเยอะมากเลยทำเยอะจริงๆงานวิจัยเรื่องวัสดุจากการเกษตรเนี่ยค่ะนะคะเยอะจริงๆนะคะแล้วก็จะเห็นว่า construction เนี่ยเยอะนะคะหรือว่ากลุ่มที่รองลงมาก็จะเป็นวัสดุที่ใช้ทางการเกษตรก็คงไม่พ้นอย่างวัสดุปรับปรุงดินหรืออะไรแบบนี้นะคะซึ่งความเป็นไปจากที่ฟังจากทางภาคเอกชนนะคะก็พบว่าตัวกลุ่มที่เป็นวัสดุก่อสร้างหรือว่าอินทีเรียเนี่ยมันมีโอกาสที่ไปถึงลูกค้าปลายทางสูงกว่าเซกเตอร์อื่นนะคะแต่สิ่งทออย่างไรหรือทางเราอะค่ะก็ค่อนข้างจะเบาบางนะคะออโตเมติกนี่ไม่เห็นเลยประมาณนี้นะคะค่ะอันนี้ถ้าเราลงถึง in canvas we found that this area is a bit combined hemp wood natural dye plants water hyacinth yeah but food peel is very interesting นะคะก็เลยคิดว่าถ้าปีหน้าได้ทุนนะคะก็อาจจะต่อไปยัง agro waste บ้างนอกเหนือจาก agri waste นะคะดูมันมีความน่าสนใจหรือการ utilize เนี่ยทำได้น่าสนใจขึ้นในหลายด้านนะคะหรืออันนี้นะคะwe also write prompt to to classify technology readiness level of research because I try to ask different university and institute and found out that they don't collect only Chiang Mai University. They have information about technology readiness of their researcher, but it's secret. Yeah. So I use prompt to classify TRL level at how many? 7. Yeah. ส่วนใหญ่จะอยู่ที่4นะคะ This was in number 4. And for real, this is developed by professor in Faculty of Economics, Professor Kampana. He is an expert and consultant for NRCT National Research Institute. He created this to classify the impact level of research. นะคะอันนี้ก็จะวัดออกมาว่ามัน generate impact ยังไงตัว E ก็คือต้องการขยายเพิ่มไหมหรือว่ารอที่จะ generate future impact หรือว่างานวิจัยเนี้ยมันไม่เห็นอนาคตนะคะอาจารย์ก็ทำตัวชี้วัดออกมาเป็นอาจารย์ทางเศรษฐศาสตร์นะคะมีตัวคำนวณโอ้โหซึ่งเคยไปฟังอาจารย์พูดอาจารย์ก็บอกว่าอย่าทำเลยคำนวณให้อาจารย์ทำมาให้ดีกว่า มันยากจริงๆนะเชิงเศรษฐศาสตร์นะคะค่ะอีกนิดเดียวท่านนะคะขอเวลานิดเดียวก็คือถ้าเป็น traceability database อีกอันนะคะที่ทางศูนย์พยายามที่จะ develop นะคะอันนี้ก็คือเพื่อตรวจสอบย้อนกลับตัววัสดุเหลือทิ้งจากภาคการเกษตรหรือว่า by-product นะคะแต่ว่าปีแรกเนี่ยจะมองที่หน้าฟาร์ม gate to gate เท่านั้นนะคะ we focus at gate to gate and use LCA framework to collect resource in the farm นะคะในพื้นที่ปลูกเท่านั้นเองว่าตั้งแต่ปลูกจนกระทั่งเสร็จสิ้นเป็น product แต่ว่าแล้วแต่นะคะถ้าสมมติเป็นตัวเส้นไหมเนี่ยมันก็จะไปสตาร์ทจากตรงหนอนนะคะไม่ได้ต้องถอยไปถึงตรงการปลูกแต่ถ้ากรณีจะดูไบโอชาหรือวัสดุคาร์บอนก็ต้องถอยตั้งแต่ปลูกนะคะเพราะฉะนั้นอันนี้ลงไปในกลุ่มแรกก็คือทางกลุ่มที่ทำไหมอีรี่นะคะเพราะว่าคุณชินแล้วก็ทำงานวิจัยกับดร.รังสิมาอยู่หลายรอบก็เลยเอาอันที่คุณชินก่อนที่มั่นใจว่าเกษตรกรเขาจะให้ข้อมูลได้อะค่ะแล้วก็พานักวิจัยอาจารย์ที่เป็นทางด้าน LCA วันนี้ไม่ได้มานะคะลงไปดูพื้นที่แล้วบางท่านก็ไปมาแล้วอย่างคุณดร.วุฒิพงศ์ก็ไปมาแล้วนะคะคุณโก้ก็ไปมาแล้วนะคะเพื่อจะดู potential ว่าเอามาใช้ประโยชน์ได้ไหมนะคะขณะเดียวกันอาจารย์ก็เริ่มทำตัวบัญชีรายขาเข้าขาออกของ LCA แล้วก็คุยกับเกษตรกรเก็บข้อมูลแล้วนะคะอันนี้จะเป็นเคสตัวอย่างเหมือน 3-4 กลุ่มเกษตรกรแต่1กลุ่มเนี่ยพยายามจะให้ได้ตัว Product ปลายทางประมาณ 10-15 รายการนะคะขณะเดียวกันก็ develop ตัวไกด์ไลน์ที่จะใช้การตรวจสอบย้อนกลับความเป็นGood practice ในการจัดการแปลงทางการเกษตรของเขาหรือจัดการแปรรูปวัสดุอะค่ะเป็น Good Agricultural Practice นะคะโดยดู reference จากมาตรฐานที่เป็นระดับนานาชาติต่างๆไม่ว่าจะเป็นแก EUDR GOTS GDP Cosmos อย่างที่คุณวุฒิพงษ์แนะนำนะคะ Circular Mark G Upcycle ดึงมาเป็นบางตัวที่จะสามารถใช้นะคะอย่างนี้ค่ะอันนี้ก็เป็นตัวอย่างของ Iris นะคะที่เริ่มเก็บ LCA ตั้งต้นแล้วตัวหนึ่งนะคะแล้วก็ได้กำลังจะถามในเรื่องของ Good Practice ของเขานะคะเพื่อจะทำคล้ายๆเหมือนกับ Transparency Supply Chain หรือว่า Digital Product Passport เริ่มต้นนะคะอันนี้ก็จะเป็นสับปะรดที่เริ่มตั้งต้นแต่ว่ายังไม่ได้โทรลงไปที่กลุ่มที่เก็บข้อมูลนะคะค่ะโอเคค่ะอันนี้สั้นๆนะคะก็สั้นไม่สั้นเลยนะคะก็ขออนุญาตเข้าสู่โฟกัสกรุ๊ปรอบแรกซึ่งจะใช้เวลาประมาณ 30-40 นาทีนะคะรอบแรกก็จะเป็นเรื่องของ Valorization of Agricultural Residues นะคะ and By-products นะคะซึ่งนี้อย่างที่เรียนไปแล้วนะคะจริงๆไม่ได้ว่าจะพูดถึงresidue หรือว่า waste ตัวอื่นไม่ได้นะคะได้นะคะแต่ว่าก็ไม่อยากจะให้กรอบความคิดมันกระจายมากนะคะก็เลยยกตัวอย่างขึ้นมาเป็นสองพืชนะคะแล้วก็อุตสาหกรรมที่เรียนเชิญหรือภาคธุรกิจที่เรียนเชิญวันนี้ก็จะมีท่านที่ต้องเรียกว่าเป็นเบอร์ใหญ่มากๆของประเทศนะคะต้องขอบพระคุณพี่น้อยดร.พีรพรนะคะที่เรียนเชิญให้นะคะทั้งคุณเชอรี่คุณวัดนะคะแล้วก็มีอันนี้ก็เขาเรียกว่าอะไรนะคะยูนิคอร์นยูนิคอร์นจริงๆเลยนะคะสามท่านนี้นะชื่นชมมากๆพอได้สัมภาษณ์แล้วโอ้โหแบบนักชื่นชมค่ะในการที่แบบสตาร์ทธุรกิจหรืออะไรต่างๆท่านหนึ่งอย่างคุณพิพงศ์ก็ทำเรื่อง Trademark Certification ใช่ไหมคะเพื่อจะสร้างแบรนด์ให้กับลูกค้าที่เป็นอินเตอร์หรือทางคุณโก้นะคะก็มีเรื่องของโปรตีนแมลงต่างๆนะคะ นะคะก็หวังว่าจะได้เชื่อมโยงอะไรต่างๆด้วยกันนะคะรวมทั้งนำเทคโนโลยีเมื่อกี้ที่เราฟังจากนักวิจัยทุกท่านนั้นเป็นแค่ตัวอย่างแต่หวังว่าจะมีโอกาสได้เป็นพื้นที่ส่วนทำหน้าที่เป็นพื้นที่ที่ให้นักวิจัยทุกท่านได้พรีเซนต์นะคะประเด็นแรกนะคะเดี๋ยวจะช่วยกันกับอาจารย์หมวยในการ brainstorm นะคะประเด็นแรกอยากจะถามว่ามีภาษาwe have the English question in the slides อยากจะถามว่าการที่เราจะเอาตัววัสดุ waste นี่แหละค่ะถามง่ายๆแล้วก็ by product นะคะแล้วก็เมื่อกี้เห็นเทคโนโลยีหลากหลายงานวิจัยต่างๆที่น่าจะอยู่ของ Hk-Lcm แล้วมั้งคะคิดว่านะคะทีนี้ตรงนี้ค่ะคือถ้าจะเอามาใช้ให้เกิดประโยชน์นะคะทางขออนุญาตไปที่ภาคอุตสาหกรรมว่าอยากจะได้ในภาพแบบไหนนะคะแต่ก่อนอื่นน่าจะรบกวนพี่น้อยช่วยตลกให้ชัดขึ้นก่อนนิดนึงไหมคะจะช่วยเปิดฟอร์
ขอบคุณค่ะเป็นคนนอกวงการแล้วนะคะคือเรียนอย่างนี้ค่ะที่sorry Professor Pan I have to speak Thai คือพี่คิดว่าตอนนี้ขออนุญาตนะคะว่าเพน